sequences and series, putting it all together. In this video, I would like to do a couple in-depth problems with you that put together a whole bunch of ideas that we've learned in this entire chapter, or this entire concept of sequences and series. So for my first problem, let's start with a function. It's called f of x. And it's perhaps a closed form function. But I'm going to write it in its series equivalent as a sum from 0 to infinity of -1 to the n times x to the 2n plus 2 over n factorial. And for the first part, let's show that f of 0 is 0 and that f of x has a local minimum at x equals 0. So I'm going to try to keep it on the screen, which means I might need to erase some of the things as we go along, so you might want to write it down as we're doing this. So f of 0. What is f of 0? Let's write out f of x. Let's at least write out a few terms. So if I plug in n equals 0, I get x squared over 1 factorial, 0 factorial, which is 1. And then n equals 1, I get negative x to the 4th over 2 factorial. And then plus x to the 6th over 3 factorial minus x to the 8th over 4 factorial, etc. Does this look familiar at all? Does it look sort of like one of the big Maclaurin series that we should know? If not, it's okay. But notice that every term in my series has a 0, so f of 0 is 0 minus 0 plus 0, etc., which of course is 0. Now, let's show that f has a local min at x equals 0. Well, what is f prime of 0? I could take the derivative and plug in, but I know that f prime over 1 factorial is the coefficient in front of the x to the first term. And since there is no x to the first term, that implies that a1 is 0, and therefore f prime of 0 is 0. So that's a good start, because at a local max or min, the derivative must be either 0 or undefined. And then f double prime of 0 over 2 factorial is the coefficient in front of the x squared term, which is 1. Which means that f double prime of 0 is 2. What's important is that is greater than 0. So by the second derivative test, if my derivative is 0 and second derivative is positive, then the function has a local min at that point. So now I will erase this to get my next problem up there. That is the next part of the problem. So for part B, let's write a series in sigma notation. Sigma, all shorthand is sigma notation. for f of x over x squared. Well, that's pretty straightforward. F of x over x squared is n equals 0 to infinity, negative 1 to the n, x to the 2n plus 2 over n factorial, and then I'll just put another x squared down at the bottom. Or you could write out every single term and see that every single power of x gets divided by x squared. But I'll do it in my general case to make it quicker. Which means we end up with negative 1 to the n times x to the 2n over n factorial. So let's look at the next part. Let's let g of x equal f of the square root of x over x squared. What function is g of x? Okay, well, let's go back into this series right here, which is f of x over x squared. And let's replace every x with x to the 1/2. So I get n equals 0 to infinity, negative 1 to the n, and then I'll do x to the 1/2 to the 2n over n factorial, which equals the sum from 0 to infinity of negative 1 to the n times x to the n over n factorial. Or, if I wrote it a different way, sum from 0 to infinity of negative x quantity to the n over n factorial. Do you recognize this series now? I hope you recognize this as e to the negative x. So let me erase again, but I'm going to try to erase just part B because I want to keep part C so we can see it, at least to start. So the final part of this problem, using e to the negative x, let's look at t sub 2 of x to approximate e to the negative x. What is the biggest possible error if we were to use t sub 2 at 1/2, at x equals 1/2, to approximate e to the negative 1/2? So I will get rid of this down here, because I remember that this is, we're dealing with e to the negative x. So let me write out e to the negative x, which is 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial, etc. And then t sub 2 of 1/2 would be 1 minus 1/2 plus 1/2 squared over 2 factorial. But the question was, what's the maximum error using this approximation? Notice that we have an alternating series. So the remainder or error, using our second degree polynomial, is less than or equal to the absolute value of the first left off term. So my error is no more than plugging in 1/2 for x and making it a positive because we have absolute values over 3 factorial, which is 1/8 times 6 or 1/48, which is the maximum error using my second degree polynomial to approximate e to the negative 1/2. Let's look at a different type of problem, one I haven't done in any of my videos. And let's start with f prime of x and define it to equal 3x squared plus 2x minus f of x. Also, let f of 1 equal 1. Give you a starting value there. Let's write the first 6 non-zero terms and if we can, and the general term for the series that gives us f of x, about the center about x equals 1. So this is one where we need to take derivatives. As far as I can tell, it doesn't look like a known one. Nothing I can manipulate. So let's start finding values. Well, I know that f of 1 is 1. Okay, I gave that to you. I know that f prime of 1 is 3 plus 2 minus f of 1, which is 4. Let's start taking other derivatives now. So f double prime of x is 6x plus 2 minus f prime of x. Let's take a few more derivatives. Let's do f triple prime of x is 6 minus f double prime of x. The fourth derivative is simply negative f triple prime. Let's do the fifth derivative, which is the negative of the fourth derivative. Do the sixth derivative. We should be able to stop here. Has the negative of my fifth derivative. So I start finding values. I have f double prime of 1 is 6 plus 2 minus f prime of 1. So that equals 4 also. F triple prime of 1 is 6 minus f double prime, so 2. The fourth derivative at 1 is the negative of my f triple prime. The fifth derivative at 1 is the negative of my fourth derivative. the sixth derivative at 1 is the negative of my fifth derivative. And I think I see what's happening here. I'm just going to get -2, 2, -2, etc., etc. So it looks like I'll have an alternating series. Let's see if I take advantage of that later on. But let's write our series. So we have f of x is f of 1 plus 4 times x minus 1 plus f double prime, 4 again, times x minus 1 squared over 2 factorial, plus f triple prime, 2 times x minus 1 cubed over 3 factorial, and then the fourth derivative, so -2, x minus 1 to the fourth over 4 factorial, and then 2 times x minus 1 to the fifth over 5 factorial. So I have my first 6 non-zero terms. Let's put down our general term. It definitely is alternating. I might need to change that to n plus 1. So I'll leave that for now. And then I have x minus 1 to the n. And then it's going to be times 2, right? Because this 2 keeps showing up again and again and again, over n factorial. And then I will check if n equals 5, for example. Let's go back here. When n equals 5, I have positive, so I really need to make that n plus 1. So let me erase this again to give ourselves some space. I'll erase the top part here. And I'll leave my function down so I can see this. All right. So let f of x equal a sub n times x minus 1 to the n. At least for n equals, say, k to infinity. And define b sub n to equal n factorial over n times 3 to the n times a sub n. Let's find the interval of convergence for the series, and we'll do n equals 5 to infinity, of b sub n times x minus 1 to the n. What does this all mean? Okay, well, a sub n is kind of my general term. It's really the coefficient, if you would, in front of my x minus 1 to the n term. So a sub n would be -1 to the n plus 1 times 2, there's always that 2 there, and then x minus 1 to the n over n factorial. And then b sub n is n factorial over n times 3 to the n times a sub n. So this is the series for which I want to find the interval of convergence. So let me get rid of this bottom part now because I don't need it anymore. And let's find the interval of convergence of this series, starting by cleaning it up a little bit. So the n factorials are gone. That's great. And then I can pull the 2 outside because I don't really care about that so much. And then I have negative 1 to the n plus 1 times x minus 1 to the n over 3 to the n. Now, if you're getting good at problems like this, I already know that I'm going to have a series centered at 1 with a radius of 3 on each side. Even though I forgot the n, but I'll put it there now. Centered at 1, 3 on each side. I can look. How do I know? I have a geometric part, these two pieces, and a linear part, which at infinity is basically nothing compared to my geometric part. But let's go ahead and show the work. This would be the ratio test, which would give me x minus 1 to the n plus 1 over n plus 1 times 3 to the n plus 1, divided by the nth term, which we flip and multiply, of course. N times 3 to the n over x minus 1 to the n. At infinity, n over n plus 1 goes to 1. Then I get x minus 1 on top and 3 on the bottom. And this will converge when I get x's that make that ratio less than 1, or when I get x minus 1 is less than 3. So all x's no more than 3 away from my center of 1. So right now my interval of convergence is negative 2 to 4. That's my interval of convergence. The only thing we're missing are the endpoints. So let's check each endpoint, and we'll plug it into this one over here on the right. Let's start with x equals 4. I'm not going to worry about the 2. That will not affect convergence or divergence. So n equals 5 to infinity. The 5 on bottom doesn't really matter either. But then I get negative 1 to the n plus 1 times 4 minus 1 to the n over n times 3 to the n. Those cancel, and we are left with a converging alternating series. So I can put the equal sign right here for my interval of convergence. Now let's look at x equals negative 2. Once again, I have my series, my sum from 5 to infinity of negative 1 to the n plus 1, ignoring the 2 out front. And if I plug in negative 2, I get negative 3 to the n over n times 3 to the n. Rewriting this one, we get n equals 5 to infinity of negative 1 to the n plus 1 times negative 1 to the n times 3 to the n over n times 3 to the n. My 3 to the n's cancel. I have 1 over n basically, which will converge if it alternates. Because 1 over n diverges by p series, but it will converge if it alternates. So I got to figure out if negative 1 to the n plus 1 times negative 1 to the n alternates. So I get negative 1 to the n plus 1 plus n is negative 1 to the 2n plus 1, which is always odd, which is always negative 1, which does not alternate. So I really have the p-series 1 over n, which means that endpoint diverges. And my interval of convergence is -2 less than x less than or equal to 4.